All right. Hello, students. It's Mr. Rich. I'm doing a live stream here this morning. I'm about 45 minutes late, but the purpose in me doing this live stream was to just get used to doing a live stream in advance of the bigger live stream that I'm going to be doing this Sunday when I'm going to be doing a full hour on AP Precalc. And that's going to be this coming Sunday, and that's going to be at 7 o'clock. But anyway, so what I'm going to do today in this live stream is I'm going to solve 5 equations that would be found possibly in a pre-calc class. And so you can see here, I probably won't be using the calculator much here unless I have time, and I'll show you some graphing solutions to these. But the first equation here that I am going to solve is obviously an exponential equation. And what we're going to try to do to solve this is we're going to try to match the bases on the left-hand side with the right-hand side. So I've got a 16 base here on the left side. So I'm going to rewrite that as 2 to the 4th power. And I will keep the 3x plus 5 exponent. But I want to match the base here with this 8 to the base 2 that I used here. And 8 is 2 to the 3rd power. And then we'll keep the same exponent, obviously. Then at this point, we're going to use our rules of exponents, and we're going to use the power rule that says that when you raise an exponent to another exponent, that you're going to multiply those together. So this would be 2 to the 12x plus 20. And this one over here is going to be 2 raised to the 12x. And 3 times negative 27 would be a negative 81. And then what we're doing is we're using kind of the one-to-one principle here, where if I've got a match on the 2 bases, then it stands to reason that this equation would be true when the exponents are the same. And then it doesn't take long to see here that we have an issue here, because when I subtract 12x from both sides, I'm left with 20 equals negative 81. And that tells us there is no solution here, because when you try to solve a linear equation here and the variables disappear in your algebra process and you're left with an inequality that's just not true, 20 is not equal to negative 81, then that tells you that there's no solution. Therefore, there is no solution to the original equation that we were solving. Okay, so let's move on. And here is the next one. I wanted to solve a log equation. And if you are watching this, let me know you're here. I would like to see. You can post a comment here in the YouTube live stream. All right, it's a logarithm. I've got log base 2, and they are being subtracted. So what I'm going to do is condense these 2 logarithms into a single log by using the quotient rule of logarithms, which says that if I'm subtracting these 2 logs, I could combine them by division in the argument of the logarithm. So I'm going to get log base 2 of x plus 5 over 4x plus 1, and that would be equal to 3. And hopefully in your pre-calc class, you've learned that logarithms and exponentials are inverse functions. And therefore, what I'm going to do to get rid of this log base 2 is I'm going to use an exponential with a base 2. I'm going to do something that we call exponentiate on both sides of the equation. I'm raising a 2 power on both sides. So when I do that here, these 2 will cancel each other out, and the left-hand side of my equation becomes the argument of the logarithm. And over here, I have 2 to the 3rd, which is 8. And what I'm going to do here is I'm going to multiply both sides of this equation by 4x plus 1. Or if you want to think of it as cross multiplying, that's another way that you could think about this. So that's going to be 8 times 4x plus 1. I will distribute that 8, giving me 32x plus 8. I think I'll move this x to the other side, giving me 31x. I will subtract 8 on both sides, giving me a 3. I will get x equals negative 3 over 31. That would be my answer. Now, let's take just a quick minute here and take a look at what this might look like if we were going to solve it using a graphing approach. So let's try this here. What I would do, a couple of things we could do to try to solve. In fact, I'm going to go back up to this first equation. Let's show why there is no solution to this. What I'm going to do here in Desmos is I'm going to graph the exponential here, 16 raised to the 3x plus 5. And to get that exponent to stick, I think I need to put that in parentheses. Okay. And then I will graph the right-hand side of the equation. So that's going to be 8 raised to the 4x minus 27, right? And as you're solving equations and you're doing homework, it's always a good idea to try to think if you could show graphically what you think the solution is algebraically. So we came up with the idea that there was no solution here. And so what I'm doing here is I'm graphing these. I've been suffering from a cold for a long time. But what you can see is apparently these functions will never intersect. They are both approaching the same horizontal asymptote, but they're, if you zoom in far enough, you might be able to see that the red line is on top of the blue line. So they're never intersecting each other. That's kind of confirms our solution, that there is no solution to the equation, because the left-hand side graph and the right-hand side graph never are going to intersect one another. If we take a graphing approach to this other one that we did, let's just see what would happen here. What I would do is we'll graph the left-hand side of this equation. Now this is a log base 2, so in Desmos, I actually need to go into the functions command, and I believe this is in the calculus section. So I'm going to give this a log base 2 of x plus 5 and minus. Let's go grab that same function. And we'll do a log base 2 of 4x plus 1. Right? And then we'll get rid of this one. So that function there, I am graphing the left-hand side of the equation. I am now going to graph the right-hand side of the equation, which is just a horizontal line at y equals 3. And if you zoom in a bit, you can see there's an intersection point, right? That the x coordinate of that intersection is going to be the solution to the equation. So that is just a general graphing approach, nothing special with Desmos. You could do this on a TI-84 as well. But when you graph the left side, graph the right side, and you look at the intersection point, that x coordinate would be our solution. Now, we said that our solution was negative 3/31. That's an exact answer. Let's just confirm that negative 3 over 31 gives an equivalent decimal answer. So negative 3 over 31 is negative 0.096. You come up here, you can see that indeed that is the x coordinate of the intersection point. So that is one way to confirm that our algebra solution is correct. All right, let's go to the next one. The next one that I decided to do here was a trig equation, tangent of 3x equals 1. And we're going to find all solutions to this. So what I'm going to do is I am going to take the arc tangent on both sides. All right, now when is tangent equal to 1? Well, there are two angles within the unit circle when tangent is going to be equal to 1. One of those is going to be pi over 4 in the first quadrant, and the other one is going to be over in the third quadrant at 5 pi over 4. So within the unit circle, 3x would be equal to pi over 4 and 5 pi over 4. Now, since these solutions are always going to be pi apart from one another, what I can do is if I'm going to express all of the solutions, what I'm going to do is I'm going to say that when an angle is going to be, when the tangent of an angle is equal to 1, that angle has to be pi over 4 and then plus k times pi, where k is an integer. And because every pi radians, there's going to be another solution for this angle when the tangent of that angle is equal to the number 1. But then our last step here is we are going to divide by 3. And so it's going to be pi over 12 plus k times pi over 3. That would give us all of the solutions to that particular equation. All right, not too bad there. All right, so another trig equation. Square root of 3 times sine x plus cosine x equals 0. And this, might be a hard one to solve in that we like to try to get the trig functions in our equation and then maybe try some factoring. Well, here, what I'm going to do is I am going to get my one trigonometric function in this equation by dividing both sides of this by cosine x. Like that, because what that's going to give me here is root 3 times tangent x, using the trig identity of sine x over cosine x being tangent. Cosine x over cosine x is 1, and this is going to be 0. All right, now I'm going to solve for tangent x. I will subtract 1 and divide by a root 3. So I'm going to get a negative 1 over the square root of 3. And this is tangent of x is equal to negative 1 over the square root of 3. Now, this is going to be also give me two answers within the unit circle. This is going to be in quadrant 2 and quadrant 4. And we're using the fact that tangent, we know, tangent of an angle is going to be the ratio of our y and x coordinates. So what I'm looking for here is this is going to be down at 5 pi over 6, right? Because when we visualize our unit circle, and we're over here in the second quadrant, when we get over here to 5 pi over 6, this is a negative root 3 over 2, comma 1/2. Now, so I think what we want here is we don't want that point, actually. I think what we want is 2 pi over 3 is going to be our answer here. And here's why. Because this angle up here at 2 pi over 3, this coordinate right here is going to be, is that right? No, I think I had it right. This coordinate over here is a negative root 3 over 2, comma 1/2, right there. That is the coordinate for this angle, which happens to be at 5 pi over 6. So I am going to change this to 5 pi over 6. Because tangent at 5 pi over 6 would be my y over x. And now I think I'm going back to 2 pi over 3. So this is going to be like this. So I'll show you what this is. This point up here is a negative 1/2, comma root 3 over 2. And we're taking our y coordinate over our x coordinate when we're doing tangent. So when you look at those 2 points right there on the unit circle, the one that's going to give me a y over x ratio of 1 over root 3 is going to be this one. So it is indeed going to be 5 pi over 6. So I think I changed that 4 times there. So, but this is going to be where my tangent is going to give me a ratio of negative 1 over root 3 y over x. Now that also means then that exactly pi radians on the other side of my unit circle over here, which would be 11 pi over 6, that would be the other angle at which the tangent is negative 1 over the square root of 3. But like I did in the previous problem, instead of listing that out right there, I'm just going to say that I just have to go out k times pi, and I will get all of the solutions to this, where k is any integer. So k could be a 1 pi, a 2 pi, a 3 pi. Every time you add a multiple of pi to 5 pi over 6, you're going to get another solution to that equation, because these are the two solutions in the unit circle. So every time you add pi, you're going halfway around. Add another pi, you come back and you pick up another solution right there. So that's going to be our answer. 5 pi over 6 plus k times pi. All right. Just one more equation here that we're going to solve, and it's another logarithm equation. And what I'm going to do here is condense these two logs on the left-hand side into one log using the product rule of logarithms. And that is to say that if the bases match on the logarithms, I can condense those into one argument. So this is going to be x times x plus 6. So these two arguments can be multiplied together into a single log base 2, and then there's my 4. Now what I'm going to do is I'm going to exponentiate with a power 2 on both sides. So I can cancel that log base 2. This is going to give me x squared plus 6x equals 2 to the 4th, which is 16. So this results in a quadratic that I'm going to solve by moving that 16 over. So I will get this, and then I will go ahead and factor this quadratic. And the two factors are going to be a positive 8 and a negative 2. I'm looking for two numbers that multiply to be negative 16, but yet they add to be positive 6. There they are. That gives me two solutions here to this quadratic, negative 8 and positive 2. Now, only one of those is going to work because I can't take a logarithm of any 0 or negative numbers. So this negative 8 is not going to work because I cannot take the log of a negative 8. So that is what we call an extraneous solution. 2 is going to work because I can take log base 2 of 2, and I can take log base 2 of 2 plus 6 or 8. So that's going to check, and that is my only solution to that particular log equation. All right, so that was 5 equations. Anyways, I hope that was of interest to you. And again, this is just kind of a test run for what I'm going to be doing this Sunday night, which is going to be a AP Precalc review. I'm going to be doing 2 of them. I'm going to be doing one on April 13th at 7 p.m. this coming Sunday, and then I will do another one on Sunday, April 27th, 2 weeks after this coming Sunday. And one of those is going to be a multiple choice focused, and one will be a free response focused. And I'll be doing both calculator and non-calculator. Okay, everybody, thanks for stopping in, and I'll talk to you later.